Very good morning, dear students. So we are discussing the chapter that is electrolysis, and with this electrolysis we are discussing the very few examples of the electrolysis which are occurred in your syllabus. So we are doing the examples, they are present in your syllabus. The first example is the electrolysis of molten lead bromide. Now as you see, it is the lead bromide. So the formula for the lead bromide is PbBr2. Pb stands for your lead. Symbol of lead is Pb, that is capital B and small b, and Br, you know this thing that the Br is a symbol of bromine atom, right? So the formula for the molten lead bromide is PbBr and 2, right beta? And after that we are using a word here that says that it is a molten lead bromide. Why we are using a molten lead bromide here? Because this lead bromide is not present in the form of its ions, and we are doing the electrolysis of the compound, and we know this thing that the electrolysis only done with the help of ions. Electrolysis can be done with the help of ions only, and this PbR2, that lead bromide, is not present in the form of ions. That is not present in the form of ions. So to break the lead bromide molecule into ions, we require its molten state, because in solid state it is not present there. So the electrodes used here are the electrodes, that is a cathode and anode. Both are made up of graphite plates, and we are using the graphite plates as the electrodes in both the cases. Either it is cathode or either it is anode, and since it is inert in nature, because graphite electrodes are inert in nature. So and the graphite electrodes further connected to the copper wires, and that is connected to a battery that is a supplier for the electricity, and that battery is a supplier for the electricity. Okay, let's move on to the next slide. So this is the diagram showing you the cell, electrolytic cell, about that cell. So that cathode is an electrode which is carrying itself a negative charge. It is carrying a negative charge, as well as it is connected to the negative terminal of the battery. And same with anode, it itself carries a positive charge, and it is also connected to the positive terminal of the battery. So as we see, opposite charges always attracts to each other. So Br negative being the negative charge and anode being the positive charge, they attract each other, and that Br negative part will go towards the positive anode electrode and just leaving its electron over there and become Br molecule. Okay, that there is the formation of Br atom from bromine ions. Same with the lead ions, Pb2 positive. This Pb2 positive ions will go towards this cathode, that the negative oppositely charged electrode, and they are getting 2 electrons. The ions will get 2 electrons from this cathode part, and they convert it to a lead metal. They convert it to a completely lead metal, complete ions from ionic form to the lead atomic form. They convert to the ionic form to the atomic form. So we say that they are converted to the atomic form here. They convert to the atoms. So moving to the next slide, what are the ions used here? So we are using only the 2 ions. First one is Pb2 positive, and second ion is your anion, that is Br1 negative. And the electrode reactions are at the anode. There is a reaction occur, that is that bromine negative is converted to bromine after losing its 1 electron. As we know, this reaction will occur at the anode. Why this will occur at anode? Because anode itself carries the positive charge, so that opposite charge is going to attract that negative charge species, right? And 2 Br molecules combine, 2 Br atoms combine to form a Br molecule. That bromine molecule is formed here at the anode part, right? And if we talk about the cathode reactions, then Pb2 positive, that ionic state of that metal will goes towards that cathode and getting their 2 electrons, and they will convert it into the lead metal. This is the lead atom. They convert to the lead atom. So the overall reaction is that PbBr2, it is present in the liquid state, and after that there is a formation of Pb solid plus Br2 is a gas. That's in a brown color or brownish color gas released at the anode. That gas is released at the anode part. Okay, so observations, what we observe in this reaction, the first observation we made that dark reddish brown fumes of bromine will evolve at the anode, because we know that thing that the bromine is going toward the anode and there is an evolution of bromine gas at the anode part, right? And silvery gray metal is lead is formed at the cathode part. At this cathode part a silvery gray metal is formed, and that gray metal is none other than your lead metal, कोई और दूसरा नहीं है, ये सिर्फ और सिर्फ आपका जो lead metal present होगा that is present there. Okay, right? So if I talk about the crucible we are using, that is the electrolytic cell. This crucible, this electrolytic cell, this cell is made up of silica, and that silica is a non-reactive species. That silica is a non-reactive one, and hence an electrolytic cell that is made up of silica, we use them because they are not reacting with our any of the electrolyte, any of the electrodes used, as well as any of the electricity passed from them, because they are also the known conductors of the electricity, right? So as solid lead bromide is a known conductor of electricity, so and attracted by the electrostatic force of attractions with each other, there is a strong electrostatic force of attraction. So we provide an outside heating to the crucible just to make that solid lead bromide into its molten state. When the it is present in the molten state, that lead bromide is present into its constituent ionic forms, into its constituents ion, and we required ions for the passage of electricity for the conduction process. That's why we are giving a little bit this heat to the crucible to maintain that molten lead bromide. And that molten lead bromide, suppose you see there is a brownish gas present at the this part is anode or cathode, so we say that this is the brownish gas that is present at the anode part. At the anode part क्या होगा आपके पास में, जो brownish gas है वो present हो जाएगा of the bromine, because anode itself contains a positive charge, and oppositely Br negative, that is the negative part we going to attract to that positive part. That negative part will going to attract the positive part. This is attraction is there, and these brownish fumes and the bromine vapors are present on that side, right? And at this part, this side, this is the negative terminal, and the negative side, that is the cathode side. This cathode itself, this cathode size is itself containing a negative charge, so it is attracting that positive charge metal towards himself. तो ये attract करेगी वहाँ से, and there is a collection of grayish color molten lead metal and lead ions, lead atoms are present there. So moving to its next part, he is saying that lead ions move towards the cathode and they take 2 electrons and become the lead atoms, because lead is containing the 2 positive charge, right? It is. Then negative bromide ions comes in contact with the anode and gives an electron and becomes the bromine atoms, right? It is also right. Then 2 bromine atoms combine with each other to form a bromine molecule. This is also right. When the 2 bromine atoms combines with each other, they will form a bromine molecule. Absolutely right, this thing. So after that thing, we know that the graphite rod remains unaffected, because we know that thing that the graphite rod we are using is inert in nature. That graphite rod is inert in nature, so they are not taking part in the reaction at any time or at any cost of the reaction, so they are inert. So on that we know this, on that graphite rod at the side of anode, we are seeing the brownish color bromine vapors are present on that side. That is our observation, right beta? Okay, now again revising this thing, what happened with the lead bromide, the molten state. So molten lead bromide we required just because that lead bromide molecule containing in the solid state, there is a strong force of electrostatic force of attraction present between the lead bromide molecules. So they will require a little bit of heat from the outside just to make the solid lead bromide into the molten state, and we required them in the molten state because in the molten state they contains the ions. And at the anode, what happens at the anode, it itself itself containing the positive charge, and bromine negative ions will move towards that anode and they convert into the bromine atoms. Further, two bromine atoms combine to form a bromine molecule, and that bromine molecule must contain a brown color vapors. So a brown color vapors will appear at the anode portion. So the brown color vapors will appear at the anode portion, and we know this, these brown color vapors are due to the presence of bromine molecule there, right? At the cathode part, we know this thing. At the cathode part, lead positive ions converted to which thing? That lead positive ions and converted to the lead metal or lead atoms, and that lead atoms are the gray color silvery metals that are present below this cathode part, and they are present at this cathode part, so we can get them. So this is the electrolysis complete process of the lead bromide, that is a molten lead bromide specifically, right? Okay, moving towards the next reaction, that is the electrolysis of acidified water using a platinum electrodes. That we are using the platinum electrodes in the acidified water, right? Here you understand this thing, we are using only a water molecule. So if I talk about the electrolyte used, then the electrolyte used is the acidified water only, that is the water in the presence of dilute sulfuric acid. So please note down here, we can there is a question comes in your mind that ma'am, we can use any other acid, like we can use here the dilute nitric acid, we can use also their dilute hydrochloric acid, why not we are using these acids here? So we are not using these acids because all these acids are volatile in nature, they escape out from the electrolytic cell in their vapors form. So we are not using these acids in the case of electrolysis or for the acidification of water in the electrolysis of water molecules, right beta? So we only use the sulfuric acid, dilute sulfuric acid, which is non-volatile in nature, that it is a non-volatile compound, right? Next is the electrodes used. The electrodes used are only the platinum foils that is present in your syllabus. The next example is also given in your book, that is with the copper and the one copper and one platinum, but that example is not part of your syllabus, so we are not doing that example. So the example that is in your syllabus is the platinum foils only, so we are using only the platinum foils example. So we use only the platinum foils example which are inert in nature. So that is inert in nature and connected again with the copper wires and the terminal of battery. That terminal of battery will provide you the electricity and process of electricity that will provided by you. Okay, so next slides will show you that the ionization of the acidified water. You see there that ionization of a H2O molecule will lead to a H positive and OH negative ions. But please listen this thing, that this is due to a typing the mistake or typing error. You need to write down this OH negative ions to this side only. आपको यहाँ पर ही इन OH negative ions को लिखना है, आप इतना दूर उसको नहीं लेकर के जा सकते हैं, तो प्लीज़ माइंड दिस थिंग, राइट? आपको यहीं पे ही OH नेगेटिव आयंस को लिखना है. सेम दैट SO4 2 नेगेटिव आयंस मस्ट बी प्रेजेंट ऑन दिस साइड. सो दिस इज द SO4 2 नेगेटिव आयंस. ये SO4 जो आपके 2 नेगेटिव आयंस हैं, ये भी कहाँ पे प्रेजेंट होने चाहिए? यहीं पे ही आपके पास में प्रेजेंट होने चाहिए. सो दैट इज द SO4 2 नेगेटिव आयंस. आई होप दिस इज क्लियर टू यू ऑल. ठीक है, राइट नाउ नेक्स्ट वी आर मूविंग टू दिस साइड, दैट the SO4 2 negative ions present in the solution, right? So if we talk about that how many ions present in the solution, so we know this thing, there is only 3 types of ions present in solution. The first one is the H positive ions, and that H positive ion is a cation present in the solution. Second one is the OH negative ions and SO4 2 negative ions. It means 2 types of anion present in the solution and only one kind of cation is present, that is only the H positive ions. Okay, I hope this is clear to you all. Now moving on to the next part. Next part is its reaction diagram. That in the diagram this is the battery supply, that is the supply of battery, and the 2 platinum electrodes we are using, and we are adding a water molecule. This blue liquid is shown to you is the water molecule, and from this above side we are using H2SO4, and that dilute H2SO4 is used in the porous form, like smallly we are pouring the dilute H2SO4 to the this container or this beaker. Okay, understand this thing, this cell. So we are using only the dilute H2SO4 in a very small amount, and rest all is the water molecule. Rest all present is our water molecule, कि यहाँ पे पूरा का पूरा आपका water molecules present होंगे. Yes, there is a liberation of H2 gas as shown in the diagram and liberation of the O2 gas. Let's discuss how this liberation will occur. So we see that the electrolysis of acidified water considered as an example of catalysis. Okay, so he said that water itself is a known conductor of electricity. Okay, and it consists of only on the molecules. There is no ions present in the water, like it contains only the H2O molecules, that all the H2O molecules are present only. So when traces of dilute sulfuric acid is added to the water molecules, so it catalyzes the ionization process, and hence water ionizes to its ions, and that ions are the H positive ions and the OH negative ions. If there is no presence of H positive ions, or if there is no presence of a dilute sulfuric acid, then water cannot be ionized into its constituent ions. It is always present in the form of H2O molecules. So if we want to make them into ions, or if we want to make the process of electrolysis to be done, so we need the ions of the water molecules, and for that we require to add few amount of dilute sulfuric acid, and that act as a catalyst in the process of electrolysis of the acidified water. So next, moving to the next slide, the reaction at the cathode. So we said that at the cathode, we know this thing, that cathode is itself containing a negative charge electrode, and he is attracting always the positive charges towards himself. So here also the only H positive ions present in our solution is the H positive ions, and that H positive ions will migrate to the cathode side, and that hydrogen gains an electron, that H positive ions gain an electron and become a neutral hydrogen atom, and after getting this neutral hydrogen atoms, two hydrogen atoms combine with each other to form a H2 gas, or to form a H2 molecule. So we understand this thing, that the H2 gas will comes out to be at the anode portion. So that H2 gas is coming to the एनोड. H2 गैस कहाँ पे आएगी आपके पास में? एनोड के पास में. सो नेक्स्ट वी आर मूविंग द रिएक्शंस एट द the H2 gas will comes out at the cathode portion, that this H2 gas is coming at the cathode side. So next we are moving to our reactions at the cathode. So reactions at the anode. So at the anode, what we see, what we observe this thing, that only the two types of anions. The first one is the SO4 2 negative anions, and second one is the OH negative anions. Now the confusion creates here, that which type of anions is now migrating towards the anode reaction, anode electrode, because anode is on a positive charge electrode itself, and it is attracting the opposite side charge ions towards himself. So that thing, when there is a selective discharge is there, then that preferentially selective discharge is depending upon the electrochemical series. In the electrochemical series, which ion is present in at the lower position, that migrates first. वो migrate सबसे पहले करेगा, that is present in the lower positions. Now if we compare for the SO4 2 negative and OH negative, we know this thing, that the OH negative is present at the lower position in the electrochemical series. So that OH negative ions will discharge preferentially on the anode. So OH negative ions loses their one electron at the anode and becomes a neutral compound, and when two neutral OH atoms combines with each other, then they will form a H2 molecule and release of one oxygen atom here, and that two oxygen atoms combine with each other and they will form a O2 molecule. There is a formation of O2 molecule. So simply you see that for the formation of this O2 molecule, we requires two oxygen atoms, right? And for the two oxygen atoms, we require two molecules of OH there and 2 molecules of OH here. It means we require 2 H2O molecule for that there is the formation of 2 H2O molecule for the formation of 1 O2 molecule, right? We discuss this thing later also, हम इसका balancing का आगे अभी बात करेंगे. So let's carry on to the another slides. Then the ratio of hydrogen to oxygen is 2:1 by the volume. So as you know this thing, this is showing that 2 OH molecules combined with 2 OH molecules to form 2 water molecules and 1 oxygen molecule that I discussed in the previous slide, right? Then 4 OH negative molecules will provide you 4 OH and 4 electrons in the reaction, and same 4 H positive molecules will get your 4 electrons to form a 2 hydrogen molecules. So we say that thing that in the case of hydrogen to oxygen ratio, we know this thing, if in the reaction 2 hydrogen atoms are formed, then there is a formation of 1 oxygen molecules only. So that is, we are saying that in a overall reaction of electrolysis of water molecule, then 2 water molecules are used, and their electrical energy, by applying electrical energy though on that, by doing the electrolysis, we only form that there is a formation of 2 hydrogen atoms and 1 molecule of oxygen. Sorry, we are saying that the 2 hydrogen molecules and 1 oxygen of the molecule. So it means that the hydrogen to the oxygen volume is 2:1, right? It's 2:1. So please do all the things, and thank you very much for watching this. Please do now. अब आई होप अच्छे से समझ में आ गया होगा कि व्हाट इज द कैथोड एंड एनोड एंड व्हाट टाइप ऑफ रिएक्शंस आर अकरिंग एट द कैथोड एंड द एनोड पोर्शन. ओके, सी यू. Okay, one thing there is remaining, that is the O2. As you see now, O2 gas is liberated at this portion, so it simply means that this O2 gas कहाँ पे liberate हो रही थी? At the cathode or anode. So O2 gas is liberated at the which portion? And if I talk about the H2 gas, then H2 gas is liberated at which portion? As you see this thing, that in the cathode, we are saying that at cathode the H2 gas is liberated. So we said that this portion where the H2 gas is released is the cathode one portion, that this is the cathode and this one is the anode side. Okay, so please remind this thing, do practice the diagram and do practice all the questions coming in between the slides, and do practice all the things. Okay, so thanks for watching. See you in the next video. With one example is left, so we are dealing with that one example also, and next we are dealing with the electroplating and that the applicatory parts of the electrolysis. Thank you.